Okay, let's dive in. Have you ever faced a problem so complex it feels like your brain is just drawing, I don't know, capricious lines in innumerable directions?
Right.
Like that quote from Gaston Bachelard you shared from the source. It's that feeling, right? Just overwhelmed, not sure where to even begin.
Yeah, that feeling of unstructured chaos. It's sort of the defining challenge of trying to solve anything complex these days, isn't it?
Yeah.
So much information, so many moving parts.
Exactly. And that's what this deep dive is all about, really. You've brought us some fascinating excerpts from this book, Green Triz to Solve Tea Sleep Problems Perfectly, by Joseph Carlos Thecavito.
Right. It's a source that promises a way to maybe bring some structure to that chaos.
Yeah, exactly. So our mission today is to really unpack this, get into the core ideas of TRIZ, that's the theory of solving inventive problems, and especially this idea of green TRIZ, and figure out how it acts as a toolkit, a systematic way to not just brainstorm randomly, but to actually invent and innovate, aiming for solutions that are sustainable too, helping you navigate those really tricky challenges.
Finding a pathway through the maze,
Yeah.
essentially, instead of just wandering.
Okay, so let's get right into it then. TRIZ. Fundamentally, what are we talking about here? And, where does the green part fit in?
Okay, so TRIZ, at its heart, it's a methodology. It came about from studying just like tons of patents, successful inventions, looking for patterns.
Patterns.
Yeah, patterns in how people solve difficult technical problems.
Yeah.
The idea was to kind of reverse engineer innovation, find the recurring principles, the strategies that led to breakthroughs. So it gives you a structured way to tackle technical problems and, foster innovation.
Ah, okay. So it's like finding the common strategies, the cheat codes maybe for innovation based on what actually worked before.
You could sort of think of it like that, yeah. It helps move you beyond just random trial and error. And green triz, which the author Joseph TK also calls trizolution in the source.
Trizolution, right?
It basically takes those core TRIZ principles, but adds this really critical focus on sustainability, eco-friendliness. It's specifically designed, he says, to tackle a wider range of problems, which he bundles under this acronym T-SLEEP.
T-SLEEP. Okay, you got to tell us what that stands for.
Right. So T-SLEEP covers technical, social, legal, economic, environmental, and political challenges.
Wow, that's broad.
It is. You can kind of think of it like pestle analysis, maybe, but framed more around problems in each area that need inventive, sustainable solutions. Green Triz aims to hit all those marks.
Okay, so it's not just about making a better mousetrap, technically speaking, it's about the whole picture, the whole ecosystem of its impact.
Exactly.
And the author, Joseph TK, the source mentions his background, DRDO, sharp Titron valve. That's quite a mix.
It is, yeah. And I think that suggests these methods aren't, just stuck in one field. Defense, consumer electronics, industrial stuff. It points to the versatility of the approach.
That makes sense. The source also makes a point early on distinguishing between creativity, invention, and innovation. That seems important.
Yeah, it's a good clarification. So creativity is just generating the ideas, right? The novel concepts. Invention is actually creating something new based on those ideas, making the thing.
Gotcha.
But innovation, that's the crucial step of implementing it, bringing it to market, putting it into practice so it actually creates value. And then green innovation, or green innovation as the source calls it.
Green innovation, I like it.
That's innovation specifically aimed at, saving the earth, sustainable impact.
Okay. So Green Trees is the structured toolbox for getting to green innovation by inventively tackling problems across that whole T-SLEEP landscape.
That's a good way to put it. It gives you the tool to channel your creativity towards solutions that are not just clever, but also impactful and sustainable.
All right, let's open up this toolkit then. The source lays out some really interesting core TIZ tools. Where should we start?
Well, I think a really fundamental concept, the one that maybe sets TRIZ apart right away, is the ideal final result, the IFR.
The IFR, ideal final result. Okay, sounds very ambitious.
It is, and that's kind of the point. The IFR is like the theoretically perfect state, where the function you want just happens with no cost, no harm, maybe even no system needed at all.
Whoa, okay, that sounds impossible.
Often it is in reality. But the insight here is by forcing yourself to envision that absolute ideal, you break free from just thinking about like small improvements to what you already have.
So instead of asking, how do I make this widget 10% better, you ask,
how does the function happen by itself? Like the source's examples. Boiling water instantly, no energy, no time. or a house that cleans itself perfectly, no effort, no chemicals.
Right.
By focusing on that, even if it's impossible, it forces you to think about completely different ways to achieve the goal. It pulls you towards breakthrough thinking, acts like a compass.
Okay, I get that. It stops you getting stuck in the mud of the current solution. Powerful idea. What's next in the toolkit?
Then there's the concept of resources.
Resources, like what materials you have lying around.
It's much broader than that in TRZ, actually. Resources are everything available. Materials, yes, but also energy, information, time, space, existing functions, even things that seem like problems or waste products.
Huh, interesting.
The key idea is to look really hard at all these things, inside the system and outside, and think about how you could use them in unexpected ways. Often the solution involves leveraging something you already had but weren't seeing as a resource.
Finding hidden value? Okay, what else?
There's a tool for analyzing the problem structure itself called the Field model.
Field, short for.
Substance field. It's actually quite simple but very effective. You model the system by breaking it down into substances, which are basically the objects or components involved, and the field, which is the energy or information that connects them to make the function happen.
Okay, like the sources example.
Yes,
Mixing liquids.
exactly. The liquids are the substances. The spoon, or maybe a motor, provides the field, the mechanical energy that interacts with the substances to get the mixing done.
Right.
By mapping it out like this, substance, field, substance, you can see very clearly where the interaction's happening, if it's harmful, if it's insufficient, if something's missing. It simplifies the picture.
Sort of like diagramming the sentence of the problem.
Yeah,
Okay.
right.
The source also mentioned patterns of evolution,
Yeah.
that systems change in predictable ways.
Yeah, that's another big part of TRIZ. Looking back at how technologies have developed, you see these recurring trends. Systems tend to move towards greater ideality, more function, less cost, less harm. They often get more complex, but also more efficient, maybe moving to micro levels, using less energy. The source lists a bunch of these trends, including things very relevant now, like, distributed intelligence and AIoT, data fusion. The insight is, if you understand these general directions of evolution, you can kind of anticipate where solutions might emerge, or even consciously try to push your system along one of these paths.
Like seeing the direction the river is flowing and using the current.
Something like that, yeah.
Yeah.
And to help you navigate those paths, especially when you hit a roadblock, you have the inventive principles. The source says there are 40 of them.
40. Wow, that's quite a list.
It is. But they're distilled from analyzing like millions of patents and innovative solutions. They represent common strategies for overcoming problems. They act as prompts, basically, to jolt you out of your usual thinking.
Okay.
The source gives some cool examples like extraction, just removing a problematic part, or nested doll, putting one thing inside another. Asymmetry, blessing in disguise, using a harmful effect to your advantage. Self-service, composite materials.
Interesting names.
The point is, these are like proven recipes for innovation. You don't have to reinvent the strategy itself every time.
They're like brainstorming prompts on steroids.
Mm-hmm.
But okay, 40 principles. How do you know which one to use when you have a specific problem, like a trade-off?
Ah, yes. That's where a really key tool comes in, the contradiction matrix. This is specifically designed for tackling those classic technical contradictions.
The trade-offs, right? Like you want something stronger, but that usually makes it heavier.
Exactly that. Or like your phone battery example, more life, but more weight. So what the matrix does is, first you identify the two conflicting parameters using a standard list of like 39 common engineering parameters, the thing you want to improve and the thing that's getting worse.
Okay.
Then you look up that specific conflict in the matrix. And based on analyzing countless inventions, the matrix points you to a small number of inventive principles, usually 3 or 4, that have most frequently been used to solve that exact type of contradiction historically.
Whoa, okay. So if I look up strength versus weight, the matrix will say, try principle number 1, or 15, or 28, something like that.
Precisely. It gives you targeted suggestions. The source had those great aerospace examples, trying to improve aircraft weight conflicts with fuel efficiency. The matrix might suggest using composite materials or universality, making one part do multiple jobs.
All right.
Or if improving engine power makes emissions worse, it might point towards mechanical vibration or maybe periodic action. The key insight is that it leverages decades of collective problem-solving experience to suggest the most probable successful strategies for your specific conflict. It saves a huge amount of guesswork.
That's incredibly powerful. It's like having a giant database of successful hacks for specific engineering problems. The source also lists all those technical parameters you mentioned.
Yeah, that list is important. It provides the vocabulary, the standard features you use to define the contradiction, things like length, weight, speed, temperature, force. But also, importantly, the source includes IT specific ones like usability, data accuracy, risk management.
Ah, so it's not just physical stuff.
Not at all. And broader ones too, like cultural factors, regulatory compliance, aesthetics, safety, environmental sustainability. It covers a really wide range of attributes you might need to improve or manage. It gives you a structured way to describe the system and its issues.
A common language for the problems. Got it. Okay, one more big tool you mentioned, the knowledge base of effects, KBE. This sounds scientific.
It is. The KBE is essentially a structured database or catalog of physical, chemical, biological, even psychological or sociological phenomena and effects from all branches of science and engineering.
Okay.
The core idea here is that the solution to your specific problem might already exist, just in a completely different field of science or engineering. The KBE helps you find it. You query it based on the function you need to perform or the effect you want to achieve.
So, if my problem is, say, how do I move a small amount of liquid precisely? I could search the KBE for effects related to liquid movement.
Exactly. And the source actually mentions that specific example. It says there's something like 130 different known scientific effects for moving liquid using physics, chemistry, biology. Way more than you'd probably think of just brainstorming in your own specific field.
130 ways. Wow. That just cracks the problem wide open, doesn't it? Can you walk us through one of the case studies? The monkeys stealing oranges, one from the source. Sounded memorable.
Yeah, it's a good one to illustrate the KBE. So the problem is monkeys raiding an orange orchard. Simple enough.
Mm.
But using the KBE approach, you'd search for effects related to, say, deterring animals, creating barriers, influencing behavior.
Okay.
This leads you down different scientific paths. You might find effects related to aversion training, maybe using motion activated sprinklers, drawing on psychological discomfort. Or you explore scent repellents that taps into biology, maybe using predator scents, or even, as the source suggests, planting lemon trees around the orchard because monkeys apparently hate the smell of lemons.
Lemon trees. Okay, that's clever.
Right. Then you might look at physical barriers that connects to engineering principles for netting or fencing design, maybe noise disturbance effects or visual deterrence. The point is, the KBE prompts you to pull solutions from psychology, biology, chemistry, engineering, diverse fields, leading to a richer set of potential solutions than just, say, building a bigger fence.
That makes total sense. It's a systematic way to bridge your problem to the vast library of existing scientific knowledge, not just relying on what you already know.
Exactly. It encourages that cross disciplinary thinking.
Okay, so we've covered a lot of ground here with these tools. The ideal final result pushing you towards breakthroughs, leveraging all available resources, analyzing systems with Field, seeing the patterns of evolution, using the 40 inventive principles, especially with the contradiction matrix for those tricky trade offs, defining problems clearly with technical parameters, and then tapping into all of science with the KBE.
Yeah, they really form a kind of integrated system for thinking inventively. It aims to make the process more, well, systematic, less dependent on just waiting for a lucky flash of insight.
And Green TRIZ specifically applies this whole structured approach to those complex T-sleep challenges we talked about at the start. Because those problems, technical, social, legal, economic, environmental, political, they aren't really separate boxes, are they?
Not at all, no.
Yeah.
And that's where the green aspect and the T-sleep framing really become important. The source gives some great modern examples of technical challenges, right? Like getting different brands of smart home devices to talk to each other, interoperability in AIoT,
Yeah, that's a nightmare.
or cybersecurity for online banking, optimizing supply chains using AI, rolling out electric and autonomous vehicles, sharing healthcare data securely. These things are inherently complex technically, and they change so fast. You need a systematic way in.
But as you said, solving the tech isn't enough if you ignore the people side.
Absolutely. The social challenges the source brings up are just as critical. Understanding how consumers actually behave, navigating different cultural views. The source mentions how symbols or colors mean totally different things in different places.
Right.
Plus, ethical dilemmas. So